Hi everyone, this is the second part of the factors versus multiple series, and in this video I'm going to say something about multiples, and I'm going to include some of the problems that many students usually face while understanding the concept of multiple. So let's go through the definition first, and then I'm going to say something about multiple, which will define the concept of multiple more clearly. First we will go through the definition. That it says that when we multiply two numbers, the result that we are getting after multiplying two numbers, we consider that number as multiple. Here in this case, if I multiply 2 and 4, I am going to get a number that is equal to 8. So we are considering that 8 is a multiple of 2, or we can say also, or in other words, we can say that 8 is a multiple of 4. So we can do that infinite number of times with different numbers. For example, if we start with 2 multiplied by 1, we get 2 is equal to 2, so we can say that 2 is a multiple of 2. So in this case we can say that. And also we are having multiple of 1, so if we do that infinite number of times, for example 2 into 1, we get a result. We consider that number as multiple. 2 into 2, 2 into 3, 2 into 4. You can go on with that. Problem here is that I'm going to show you that. Alright. Yeah. So if we don't consider whole numbers, so in the definition we have to consider whole numbers, right? Here we have whole numbers, but if we don't consider a whole number, what do we get? For example, if I consider a rational number over here, and if I am multiplying that with another number, then I'm going to get 1. So is this considered to be a multiple? You know that a multiple is something when we multiply something. This is what we have, right? So it should be correct in this scenario as well, but in reality it is not true, because why we find multiples, why we find factors, that because we usually deal with whole numbers, right? While finding least common multiple, or like for finding highest common factors, we only deal with positive numbers. But in this case, if I'm considering 1 by 2, which is a rational number, which does not define any least common factors or multiple, so for that specific idea we only consider whole numbers. So yeah, in this case this doesn't suit well. So in the definition that we have here is that we only consider whole numbers. So that is a pretty much basic problem that we have here. And one more thing, that 0 multiplying by 3 is equal to 0. Can we consider this thing as a multiple? Yeah, we can consider 0 as a multiple of every number, but there is a contradiction that we might see. We consider 0 as a even number, but 3 is not an even number, it is an odd number. So how come even number, a multiple, this 0 is right here, is a multiple, how come this even number have a factor that is odd number, right? So we usually don't consider multiple 0 as a multiple of the numbers, but yeah, in scenario, if you want to consider 0 as a multiple of all numbers, you can say that, yeah, but the minimum number or the least common multiple, we only consider numbers which are equal to that number which we are finding. For example, 3 multiplied by 1, we usually start from that. For example, another case that I have given over here, that is 5 is multiplying by this number right over here, and you're getting 8. So can we consider this 8 a multiple of 5? No. So the same scenario goes like this over here. We cannot consider, because the part right over here is not it does not belong to whole numbers. So we have to consider that these two numbers are the factors of 8. For example, in the first case that we have here, that is we have the multiple for 2 and 5, we are having 10 as a multiple of 2 and 5, right? So we can say that 2 and 5 is also a factor, and we can say that 1 is also a factor of 10. So every number has a factor of 1, so there is no doubt in that. And we can say that 2 is a factor of 10, right? And 5 is also a factor of 10. This scenario suits well if we only consider whole numbers, but in the previous case, if we do consider some other number other than whole numbers, the concept get collapsed. And one more thing that I want to say something about multiples. Now we can draw some analogy from here, what we have understand about the concept of multiple. That is, for example, if 3 is dividing a, so we can say that a is a multiple of 3, right? A is a multiple of 3. For example, here in this case I consider a equal to 9, and we know that 9 will get divided completely by 3. So here 3 into 3 we will get 9. That is 9 as a multiple of 3. So 9 has a factor of 3. That's it. So and we usually find least common multiple of two numbers. That is, for example, we have 24 and 8. If you list out all the factors of 24 and also all the factors of 8, you will eventually get and find easily the least common multiple of these two numbers. Here 24 we get, so the 24 is the least common multiple which these both numbers can divide. So yeah, 8 can divide 24. 24 once goes 24. So yeah, this, if you go lesser than that, you cannot multiply these both numbers. For example, if I consider 16 is a multiple of 8, but 16 is not a multiple of 24, so we cannot consider 16 as a multiple of both numbers. So the least number that we can take is 24. Yeah, so there are and we have a lot of tips and tricks for finding LCM of two numbers without solving all these things. So you can check their videos on internet, you can find it easily. And pretty much everywhere we can use multiples. For example, this is generalization of that. That is, if the distance is the multiple of time and speed, it is just a generalization. And also after that we can make some understanding out of this. That is, multiple will always be greater than or equal to n if we don't consider 0 as a multiple of a number. So we have to keep that in mind. So this is pretty much about multiples, and hope you like my video. Or if I miss any point or something like that, please comment down below. And yeah, thank you very much.